Hi everyone, I'm Sangwoo Kim. In this video, I would like to share how to calculate Cronbach's alpha in Excel and R. Cronbach's alpha has been used to measure reliability or internal consistency from data. I will explain it by two separated video clips. Here, the first video is about how to calculate it in Excel based on R output. In the second upcoming video, I will explain it more focused on Gutmann's lambda 6 and interpretation of R output. This is Cronbach's portrait. According to Cronbach's article, alpha is an estimate of the correlation between two random samples of items from a universe of items. The expression of items in the abstract is same as variables as a statistical terminology, I guess. And the index Rij bar derived from alpha is shown to be an index of inter-item homogeneity. That's why Cronbach's alpha is one of the commonly used measurements for reliability. Let's calculate Cronbach's alpha from simple example. I have prepared 6 variables and 20 observations. Q6 is reversely coded to help you understand how to interpret the result. Let's see the scatter plot between Q5 and Q6. As you can see, there is negative correlation here. Once you get Cronbach's alpha, you can judge the index quality based on this table. This is the formula to calculate Cronbach's alpha. In our program, once you activate psych library, you can use alpha function. Then you can get this main outputs from row alpha, and also there is standardized alpha and G6 and median R. Okay. So let's calculate total from raw data by using sum function. Right, and let's calculate variance for each variable. Okay. And our program provides standardized alpha, so let's standardize raw data here. So let's use standardized function. X, average of Q1 and standard deviation from Q1. Press F4 2 times. Right, this is a standardized metrics from raw data. So let's also calculate total by using sum function. Okay, and also let's calculate variance of each variable. Then it should be 1 because the data is standardized. Okay. So this is the variance of total variable. Right. So from raw data, let's calculate n here. N is number of items. So it is same as number of variables. So count A. Right. There are 6 variables, and sum of variance is sum of variance of each variable and variance total here. Right, then we can calculate row alpha. So n over and minus 1. And multiply by 1 minus sum of variance over total variance. Okay, 0.709, 0.709 here, right? Okay, let's calculate standardized alpha here. So n equals count A and sum of variance should be 6 because it is standardized, and total variance from standardized data is here. Okay, and let's calculate standardized alpha here. So n over n minus 1 multiplied by 1 minus sum of variance over total variance here, right? 0.714, 0.714 here, right? I will calculate Gutmann's lambda 6 in the next video, so let's skip this one. And in order to get average R and median R, we need to calculate correlation matrix. So click Data tab, and on the right side choose Data Analysis and click Correlation. Inf range from J2 to O22 here, and check labels in the first row, and let's see the output in this spreadsheet here. Okay, so this is correlation matrix from standardized data. So let's delete diagonal elements, and average R is average of all correlation elements. Yeah, 0.294, 0.294 here, and median R, you can use the median function. S over n means signal over noise. So we can use signal from standard alpha over 1 minus standard alpha. Alright, so if you have 0.8 standard alpha, signal over n goes up, right? So if you have 0.95, then it goes up. So when you have higher Sn over S over n, it means that you have got good quality of standardized alpha, right? Right. Let's calculate mean and standard deviation here. Mean can be calculated from average function, average of total raw data here. Yeah, this one. And standard deviation, so we need to calculate average of each observation from Q1 to Q6. Okay, standard deviation. Right, 1.16, 1.16. ASE means alpha standard error. Until now, I haven't found any good documents to calculate alpha standard error. So just let's leave it there. So once I have good quality of documents to calculate alpha standard error, I will upload related video. So let's leave it there, 0.02418, right? Okay, so this is overall explanation about how to calculate Cronbach alpha. And as you can see, the correlation related to Q6 is negative, right? So it means that we need to code Q6, opposite side, right? So when you get this Cronbach alpha output, if you see the big gap between Cronbach's alpha and G6, there is some thing you need to check. For example, we need to, as I mentioned, Q6 has like negative correlation. It means that we need to code it reversely. In R, we can do it quickly. I mean, we can do it by changing the option. But once you get the output here, you need to understand what it means. So again, when you have Cronbach's alpha and Gutmann's lambda 6, you need to consider why there is big difference here, right? So again, if you have correlation metrics like this, you can see that Q6 has negative correlation compared to, versus other variables. It means that you need to consider changing Q6 coding method, like in opposite side. I hope it is useful for you to understand Cronbach's alpha and related other information. That's it for today. Please click like and subscribe if it was useful for you, and looking forward to seeing you soon. Thank you.